Chapter 14. The Periodic Table. Part 1. Features and Trends. Elements in the periodic table are arranged in order of increasing proton number. Vertical columns of elements in the periodic table are called groups. Elements in the same group have the same number of valence electrons. For example, elements in group 17 have 7 valence electrons. Elements in the same group have similar chemical properties. Horizontal rows of elements in the periodic table are called periods. Elements in the same period have the same number of electron shells. For example, elements in period 3 have 3 electron shells. Across a period, the elements change from metals to nonmetals. Metals are normally solids with high melting and boiling points. They are shiny, ductile, malleable, and good conductors of heat and electricity. Nonmetals are gaseous or volatile liquids or dull, brittle solids with low melting points. They are poor conductors of heat and electricity. In forming compounds, metals tend to lose electrons, while nonmetals tend to gain or share electrons. Across period 3, the oxides of the elements change from basic to amphoteric to acidic. Part 2. Group 1 elements. The alkali metals. Properties and trends. Physical properties. Group 1 elements are shiny when freshly cut and are very good conductors of heat and electricity. Unlike most metals, they are soft, have low melting points, and have low densities. Down the group, melting and boiling points decrease while densities increase. Chemical properties. Group 1 elements are very reactive as they have just 1 electron in their valence shell and have a high tendency to lose 1 electron to achieve a stable, noble gas electronic configuration. Group 1 elements react vigorously with water, forming hydrogen gas and a soluble metal hydroxide or alkali. That is why Group 1 elements are called alkali metals. Since Group 1 elements have a high tendency to lose their valence electron to obtain a stable, noble gas configuration, they are powerful reducing agents. Down the group, the reactivity of the Group 1 elements increases. Their reducing power increases down the group. This is because, down the group, the size of the atom increases and the valence electron is further away from the nucleus. Hence, it is less strongly attracted and more easily lost. Part 3. Group 17 elements. The halogens. Properties and trends. Physical properties. Group 17 elements have low melting and boiling points and are colored. Under room conditions, fluorine is a yellow gas, chlorine is a greenish-yellow gas, bromine is a reddish-brown liquid, and iodine is a purplish-black solid. Note that iodine can exhibit different colors in different states. In gaseous state, it's a violet gas, and in aqueous state, it's a brown solution. Down the group, melting and boiling points increase and color intensity also increases. Chemical properties. Group 17 elements exist as covalent diatomic molecules. They are very reactive as they have a high tendency to attract 1 more electron to attain a stable noble gas electronic configuration. Hence, Group 17 elements react with most metals to form metal halides. When a halogen atom takes in 1 electron, it becomes a negatively charged ion or anion. The halogen anion is called a halide. For example, when chlorine atom takes in 1 electron, it forms the negatively charged chloride ion. Since Group 17 elements have a high tendency to gain an electron to obtain a stable noble gas configuration, they are powerful oxidizing agents. Down the group, the reactivity of Group 17 elements decreases. The most reactive halogen is fluorine, and the least reactive is iodine. Their oxidizing power decreases down the group. This is because, down the group, the size of the atom increases and the valence shell is further away from the nucleus. Hence, it is more difficult to attract an additional electron. Other than reacting with metals to form metal halides, Group 17 elements also undergo displacement reactions. In a displacement reaction, a more reactive halogen displaces a less reactive halogen from its halide solution. For example, chlorine gas, when bubbled into a solution of potassium iodide, displaces iodine to form aqueous iodine and potassium chloride. This is because chlorine is a more reactive halogen than iodine. In the reaction, the color of the solution turns from colorless to brown. On the other hand, when bromine is added to potassium chloride, there is no reaction since bromine is less reactive than chlorine, so it cannot displace chlorine from potassium chloride. Halogen displacement reactions are redox reactions. The more reactive halogen is reduced, while the less reactive halogen is oxidized. Part 4. Group 18 elements, noble gases. Group 18 elements are colorless, odorless, and monatomic gaseous elements at room temperature and pressure. They have low melting and boiling points and are insoluble in water. As they have fully filled valence shells, Group 18 elements are chemically inert. They do not gain, lose, or share electrons to form compounds. Part 5. Transition elements. Transition elements are found between groups 2 and 13. Transition elements are metallic, so they are also known as transition metals. Transition elements have high melting and boiling points and high densities. Transition elements have variable oxidation states. Transition elements form ions with different oxidation states. For example, iron has an oxidation of +2 in iron 2 chloride and +3 in iron 3 chloride. Transition metals form colored compounds. Compounds of an element have different colors at different oxidation states. Transition elements and their compounds are good catalysts, which are used to increase the speed of a chemical reaction while remaining chemically unchanged at the end of the reaction. End of Chapter 14.